this. Okay, so I'm just going to give a really tiny introduction into what is an agent-based model, what agent-based modeling is about in the first place. Very much tailored, not going through all possible ways agent-based modeling can be used or work, but very much focused on what Jim is going to pick up later in terms of agent-based modeling for schools research and within the SOCITS team. And now it's not going forward either. Oh, there we go. So what is agent-based modeling? Agent-based modeling is a computational method that enables a researcher to create, analyze, and experiment with models composed of agents that interact within an environment. So now I can stop my introduction because I have introduced you to agent-based models. No, so this is a sort of quick introduction of what it is. It's a computational modeling method. So you design a computer program, and you use this computer program to understand dynamics between people, between agents within an environment. And the definition is from Gilbert 2008, which is a little sage book called Agent-Based Models. It's a very, very nice little book. So just to go through what we have, the ingredients of an agent-based model. In the beginning, there was nothing, and then they grew an environment. So we have an environment, something where we can put stuff in, like think of it as a room or a lawn or a common or whatever it is. And in this environment, we have some agents. So for example, some people that are scattered around. Okay, so now we have people in an environment, agents in an environment, and these agents have interactions. So just going back to this, to the definition that we have a computer program that replicates agents interacting with each other in an environment. So that's what we have here. We have some sort of, they are linked together in some sort of way. So maybe they're friends, for example. And these agents, what they do is they are autonomous in agent-based models. And what that means is that they are moving, or that they're making decisions on their own. Each agent is going, okay, I'm going to move a step. I'm going to turn a little bit and then move a step. That's what they're doing here at the moment. Note that all the interaction links are remaining. They're just moving about in space in the environment. And we can give them some more complicated behaviors rather than just moving arbitrarily a step to the left or the right, and say something like, follow my friends. So now we have these agents in an environment that were linked to each other as friends. And now we ask them to move, to follow their friends, follow the people they're connected with the links with. And voila, we're already getting an interesting behavior of the model in some ways, because we randomly linked these agents up. And now we have two friendship groups, one very large friendship group and one very small friendship group in the top corner. Okay, so this is what an agent-based model is. Literally, it's agents in an environment with some behaviors. But what is important about agent-based modeling is how these models manage to connect the individual, their context, and their behavioral decisions. So really the absolute crux of agent-based modeling is what can be called the agent-centric perspective. And that's what I had with when I talked a bit about autonomy, each agent is moving into, a step to the left or the right, or I follow my friends. It's in an agent-based model, each agent is every time step they're making a decision saying, okay, here is me, this is my context, and these are my behavior options, and I'm choosing what I do. Okay, and this is for every agent in an agent-based model. This is what's happening. So we have each agent deciding their behavior autonomously within their context. What agent-based models are particularly good at, and I'm just going to go into three aspects of agent-based modeling that are really important for SOCITS and for setting up for Jim, what he's going to talk about in terms of the agent-based model for SOCITS. They're really good at modeling heterogeneity. By heterogeneity, we mean diversity, difference, dissimilarity between agents. So a lot of methods, or many methods, are taking averages across a population. Agent-based models are great at bringing out heterogeneity, saying there are certain agents that have certain attributes and a set of behaviors that are different from other agents. Let's see what happens when they interact with each other, and with each other within the group and between groups, for example. And here we have a little example. This is a model called Party. And in the model, we're starting off with, I'm just going to go back, we're starting off with mixed sex groups at the party, but the agents have a slight preference to be in a single sex group. And what they do is, as the model goes about, they're just arbitrarily leaving the group they're in and going to another group. And we're ending up with these different size single sex groups along the way, and all of the agents being happy in the end. So here we're modeling it's very, very small amount of heterogeneity. It's just different genders and that they want to be in single sex groups. But this is a simple model that shows what an agent-based model can do here. A second really important thing about agent-based models is that they can model nonlinearity and power laws. And this is a network model called preferential attachment. And what it does, here we have two nodes and a link between them. And a model of preferential attachment networks has the rule that a new node is added and is attached to a node that's already there. And the likelihood of which node it attaches to depends on how many links the node already has. So a node with many, many links already has a higher proportion of being attached to. And we're getting this kind of structure where new nodes are coming in. You can see them attaching to existing nodes, and we're getting these some nodes within the network that have a lot of other nodes attached to them, and then some nodes that have almost none. And these are patterns that we can really find in the real world. For example, if you think about websites, then my website is somewhere over here. Maybe if I'm lucky, one person links to them. But if you think about the BBC website or the Reuters website, they're really connected to almost everybody. Everybody, lots of people link back to the BBC News website, for example. So you're getting these power law distributions and nonlinearity. And this one is probably the most important aspect of agent-based modeling that agent-based models can do, which is to show emergence. And emergence is a property that that is the result of interactions of system parts of a property that cannot be attached to the system parts. And a traffic jam is one of the best examples, because one car cannot be a traffic jam. But if you tell cars to just drive in a circle and you tell them to just keep a distance from the car in front of them, you get this emergence of a traffic jam really quite quickly by them, braking and stopping. Yeah, so you can see the emergence here of a traffic jam. And of course, we can model this in an agent-based model. The simple behavior rule is if the person in front of you gets slower, you start braking a little bit, and you see the emergence here of that same kind of traffic jam that is also moving back, as we've seen in the real life experiment of the cars driving around. So agent-based modeling is a computational method that enables a researcher to create, analyze, and experiment with models composed of agents that interact within an environment. So we've seen that. And what it really does is it helps you to understand how heterogeneity, how diverse individuals and their interactions and influences between each other can create particular social contexts, and how then these micro behaviors in the context can lead to macro patterns across a particular social situation. And that's where I finish and hand over to Jim. Does anyone have any questions? I think we shouldn't take questions here really unless there's something really important, because things will get clearer as Jim talks about the SOCITS model, I think. Okay, then I'll hand over to Jim.
Okay. Can you see my screen?
Yes.
Okay, thanks, Corinna. That was, yeah, brilliant and a great introduction to agent-based models. So what I'm going to talk about now is kind of using these ideas to think about adolescent mental health in schools research and the sort of things that we've been doing in SOCITS based on these ideas. Just to say that this is the team, so Corinna there, along with myself, are the main agent-based modelers, and yeah, we have a very varied team of psychologists and network scientists and people from the Mental Health Foundation. So yeah, so what I'm going to kind of expand on is how can agent-based models contribute to adolescent mental health research? And what I want to kind of focus on here is this idea of these nice ideas around non-linearity and emergence, but also just sort of dynamical thinking. How can sort of taking those ideas help to understand kind of adolescent mental health in schools? And what I want to say is, obviously, building an agent-based model requires some sort of computational technical expertise. What I'm going to present today are some methods we've had where, inspired by ABMs, we've kind of developed participatory tools. And even when you're thinking about an ABM, what I want to try and communicate is, even if you don't actually put the rules into a computer, understanding what those rules might be is still a very, very useful exercise in terms of understanding your system. So with that in mind, there are 4 ways I think that agent-based models can really help us all kind of understand adolescent mental health. So the first is that using these ideas behind an agent-based model can really help us understand features that are important in the school. The second one is that using the model as a boundary object, so this idea in complexity science of a boundary object being something you can discuss, can really help with discussion amongst our stakeholders, essentially. So rather than having something where you say, a student to a teacher, teachers are really unfair around uniform. If we have a model there and we're talking about our little dots moving around, what you can have is a student say, I think that in this model, it's not right that the teachers interact the same with all students. And so you can kind of understand that. And then the last 2, we can begin to think about the dynamic consequences of our different perspectives. So different rules, what are those consequences? Do they need to lead to non-linearities? And also, finally, if you have a model you're happy with, you can then, in the computer, test out different ideas. Okay, so what does our model look like? Here is our school. The tiny boxes at the top are classrooms where those sort of dots are going. The sort of grill-like patterns, that's the stairs. And then we have a corridor. So on the left-hand side is an upstairs with some classrooms and a corridor. The right-hand side is a downstairs. And then we also have a canteen. The very, very light blue individuals are the teachers. And then the sort of coloured dots here are the students, and the colour is essentially how stressed they are in our model. And so the first thing we have to think about when we're thinking about agent-based models is, as Corinna was saying, you know, I am my agent, I'm the focal person in my world. What do I do and how do I decide to do that? And more importantly, as a modeler, how do we decide how they decide what to do? And so from this, we have built our model. We built it from a number of different sort of pieces of information to try and build a nice model of our stakeholder schools. First of all was our initial discussion with our youth advisory board. So our youth advisors are young people just out of school, and they have been advising us throughout this project. And one of the things is we've had lots of discussions with them about the model. The second is kind of general academic literature. What is the academic literature? What do people, you know, why does academia and research say that students feel stressed or lonely? The rest of the SOCITS team, there's lots of different expertise there. And finally, kind of participate in school, which is what I'm going to focus on in a bit. I know a lot of you have come to all of the webinars this time, and we really appreciate that. So I'm not going to spend too much time on this, but for those who haven't been to previous webinars, there have been a number of participatory methods that we've used to generate our model. The is sort of walking interviews. So we gave students some iPads, asked them to walk around school and tell us about the school. So they might walk through a corridor and say, oh, this is a bit sort of dark and dingy, I don't really like it, and often it's very crowded and I can't get to my locker and I find that stressful. Or this is a really nice piece of art on walls, and when I look at it I feel really inspired. And then we also have what is on the right here, which are what are called the SOCITS squares. And here we ask about very specific situations. So here we have uniform. On the right, we asked about emotions, or sorry, on the left. And on the right, we asked about interactions. And interactions was the first way we tried to use this idea of an agent-based model to sort of best understand what was going on in situations. So we ask, how are people interacting? From this, we generated lots of rules for our model. I'm just going to share a few of them here for you. Don't really have time to explain the entire model. And please at the end ask questions about what is and isn't there if you're interested, but I'm just going to share key rules. So one rule we have is this idea of stress decay. So basically, if nothing else happens, stress just decreases. So in the morning, if I'm really stressed and nothing happens, by lunchtime, I've kind of moved to low stress. And that's the kind of first rule. And in the model, that basically looks like a red dot just sat there turning blue. Another thing that came up is classroom decoration and time of year. So this was really great information we got from the walking interviews, kind of asking people to walk around the school and tell us about features. This often doesn't get included in agent-based models. The environment is often sort of ignored or simplified. And we actually got really rich data about kind of what people thought about different places and times of year. So for example, in the model, essentially, each agent each room has a kind of baseline stress that they feel. And also we can turn the baseline stress up on everybody up or down, depending on if it's, say, Christmas or exam time or something like that. So here, this student doesn't like maths, and they're in maths, and it's Christmas, and so they're high stress. But if they're in art class and it's Halloween, they kind of feel low stress. And so different rooms and different times of year have different stress. And this is kind of a big piece of heterogeneity in the model, that in a room, not everyone feels the same about that situation. We also have crowdedness. So crowdedness came up a lot as kind of key driver of stress in schools and corridors and places like that. So here, these students, lots of them together have high stress, and those two on their own have no stress. And essentially the rule in the model is if there are more than a set number of people in the location, everyone becomes stressed. We also have guardianship. So this idea that basically teachers might affect how individuals feel. So on the left here, they have high stress because they're all together crowded and there isn't a teacher. And on the right, there is a teacher and it's decreased stress. So if a teacher is around, stress is decreased. And so what we can have in our model is the location of a teacher is very, very important in terms of what the stress of the student body is that it feels. And then finally, we have these ideas of kind of interactions and kind of these feedback and dynamics in the model. And so here, the boy on the right has a negative interaction with the girl on the left. That could be bullying, it could be shoving. We kind of abstract it in the model. We don't really sort of specify what that is, but that increases her stress. But increased stress causes her to have a negative interaction with him or somebody else around, and that increases their stress. And so you get these kind of cycles of stress and negative interactions, essentially. And so, sorry, I can't read what's down there. Negative interactions increase stress, and stress increases the chance of a negative interaction. So these are the sorts of rules that we have in our model. And putting it all together, we get the model. So yeah, on the left here, we have dots moving around, choosing who they move with, where they go, depending on what time of day it is. And on the right is a sort of output that we might get. So stress is on the y-axis. These units are arbitrary, right? The numbers in our model are, it's not sort of 5 on a Likert scale or anything like that. It's really just more or less. And time is on the x-axis, how much time is passing through the day. And we can kind of have a look at how stress changes for agents. One of the important things here is we do kind of in these models get dynamics like this, where we see somebody quite stressed at the beginning of the day and not or having stressful periods, or some people being completely unstressed. So I'm just going to take a drink. This first question, how can these agent-based models contribute to adolescent mental health research? Well, first is to use these ideas of dynamics and the model to better understand features that are important in your school. So what I'm going to present now is a kind of participatory, what we call the interaction sheet, that basically, even if you don't intend to build an agent-based model, you can still use to kind of tease out very important features from your school. And I'll kind of give some examples around that. So we developed an interaction sheet based on the kind of ideas that Corinna was sharing originally, this idea that in an agent-based model, you have an environment and then you have some agents and then they do stuff. And so here we basically ask, what's your environment like when nobody's around? Who else is there? What are the agents? How are people interacting? And what are the consequences of that? So sort of in the top right here, you can see this little box with just a dot in it. So this is a kind of our picture of what we're interested in. So we asked students in schools, around tables, what's important about the situation without other people? So what does the situation feel like? What do you want to happen? Okay. We also wanted to use this as a way to generate ideas around interventions and also like find out by asking what they think could be better, what they really think of the situation. So on the second half of it, we asked what things could change the situation. When we're facilitating this, it's really important to say, we want to know, like, you can say anything. It doesn't have to be true, right? So they could say, we want school to be cancelled, or there to be no boys, or anything like that. And by starting off in an sort of realistic way, you can begin to sort of narrow down to maybe more realistic interventions. So what's the sort of data we got from this? Well, in a situation for outside areas, what does this situation feel like? A peaceful, pleasant space. What do you want to happen? More people accessing this space. And then what things could change the situation? More seating areas. So these already are generating kind of ideas about understanding this space. One thing I would say is that actually part of this was motivated by the walking interviews giving us all that rich data about situations without other people. That is actually a much better way to generate that information than this. I think this is a good question to ask, but actually most of the information in the model for kind of empty spaces was really generated from walking interviews. The next question is like, who else is there? We really want to know what agents are there, but also asking this question can kind of help you get an idea of the situation. Is it older kids that are there that are causing stress? Is it a lack of teachers? So asking about corridors, who else is there? We've got answers like staff en route to class, etc. Who else would you prefer to be there? Friends, certain friends. Here again, we're kind of getting information around sort of real socially situated information, right? So who would you prefer to be their friends, but certain friends? Well, that's kind of interesting in that it's really certain people that are really important in terms of stressful situations. Then we ask, how do people interact? So that's our picture at the top, where we have those two dots interacting with an arrow. And so we ask a question about how do you interact? Talking, moving, avoiding. How do you interact with those people? How do they interact with you? Why do you or they want to do these things? Right, as many reasons as you can think of. So this kind of second box here, we're kind of trying to ask about goals. When we're building our agent-based model, we really love people to say something like, I shoved them because of X or something like that. That's actually a really difficult thing to do. Part of this was to find out what sort of data we got and whether it would work. And then we wanted to ask, how can people change how people interact? Like if by asking that, we hope to also generate rules and kind of intervention ideas. Again, in corridors, how do people interact? People are on their phones and actually avoiding. So that's a really interesting behavior that we haven't actually put into the model yet, this idea that people maybe when they're in corridors avoid each other and kind of go to their separate spaces, but also this idea of shoving places to get to places quicker. And this has actually come up a few times in terms of what causes stress in schools. This idea of being late and not being where you're meant to be being really stressful. What things could change how people do interact. So actually one student suggested they should give coping mechanisms for these ideas around shoving or having to get places quicker. And then this person suggested if people's friends aren't there, then they are less likely to mess around. So again, we're getting this information about sort of how people behave in social situations is very situational depending on who is there. Finally, we're asking after this, what happens to you? So really we're using this to sort of think about dynamics in our model, essentially, and also in the system. So trying to get people to think dynamically, what are the consequences of what's happening here and how can we solve that? And so here for group work, what after interactions, how do people feel? And in this case, they said they were anxious working on this project. Did you or they get what you want? Depends on the teacher and their opinion. Again, heterogeneity based on kind of his responses, that actually interactions really depend on which student and which teacher is interacting. And finally, what things could change how you feel then or later. If you're friends, I always find this one really hard to read out. If you're with friends, you'll be happy to work in a group again. So again, these kind of social situations. So from this, we're really learning about what are the good social interactions, but also the sorts of rules that should be put into a model. Are questions like, is an agent with their friend? How do they interact in those ways? We also introduced this exercise to kind of validate the rules in our model. So there's always a question of kind of how do you know that what you're modeling is true in your computer? But actually what we want to do with this as well is by doing this, even if you're not building your model, if you're not planning to build the model, you can still generate these sort of ideas of how agents might interact and then ask people, do they agree or not? And that gives you lots of nice information. So here on the left, we have a list of all of our rules. So we have the deep breath effect, which is essentially this idea of stress decay. If nothing else happens, stress decreases. How rooms look, time of year, that kind of those rules that I was talking about, crowdedness, guardianship, and then some other rules around social support or interactions around uniform. And then we have this little description of the rule. And essentially what I did is presented the rules in exactly the way that I presented to you about 10 minutes ago in terms of the stress and stuff. And then I just said, okay, do you agree or disagree with this? And we gave everybody little stars. And here are the kind of results that we got from this exercise. So basically the numbers here are the number of people who voted for this particular, how much they agree. And then there are some nice comments here that I can talk through. I think the really important thing again is this is very heterogeneous. Like there are very few rules where people completely disagree or agree. The one where we get totally agree is actually the most sort of inoffensive rule, I guess, that some times of years are different, more stressful or not for others. And really that's just thinking about exam times of the year. But we did get some totally disagree. So for the different rooms have different stress, there were some people who disagreed. And there was a comment there that actually the look of the class doesn't bother us. It's more the environment. So it's not really the color of the paint on the walls, but there is a kind of feeling that's still important. There were other questions about guardianship, depends on the teacher and what they're doing. And yeah, results of negative interactions. You may not do anything back, but it may affect your mood and how you interact with others for the rest of the day. So again, by thinking about ABM, it sort of naturally brings out these sort of questions and discussions around dynamics, like what are the consequences of what's happening? It's not just thinking about a single time, but the whole day. So the second way that agent-based models can contribute to mental health research is that we can use this model as a boundary object. So like I say, we can use it for discussion among stakeholders. I just want to give some examples of this. So really, it's important to say that this model is freely available. It's on GitHub. There was a website earlier, and I'll put that website up again. But essentially, even just having this little picture of dots moving around a school and being more or less stressed is kind of enough to be able to begin to talk about dynamics. And so with the youth advisors, we kind of present the model and we do it in a similar way that I'm doing today. And we say, okay, what else, what are we missing, or what seems right or wrong? And they had a really nice discussion there about lateness, and essentially how the thing that makes them most stressed in school is if they're going to class and they're getting there and a door is shut, so like a fire exit is shut, and they're effectively, and therefore they have to go round, and that makes them late. And they get stressed by that, and they're really stressed, and they're really stressed when they get into the classroom. But they were also this brought up some really interesting conversations about the consequences of that in terms of if they're stressed, their teacher's stressed, the teacher might take that stress for the rest of the day. And so a single stressful event that actually kind of propagates throughout the whole school. And that's the sort of thing that agent-based models are really great at examining, this kind of non-linearity, this idea that you could have a small number of individuals stressed at the beginning of the day, and that can propagate throughout the school in ways in which you could deal with that. The other thing is that we were able to kind of talk about this picture on the right with them, which is about stress and group size. So basically saying, okay, if you're in a group in a corridor, like what's the best number? And they said, well, sort of middle range, because if it's small, I feel lonely, but if it's large, I feel overwhelmed and anxious. And there's sort of other behaviors like shoving. And so we're able to take that and put it directly into the model. Other thing that we did is we presented the model to one of our participating schools. And so we presented it to teachers and said, okay, what do you think? And we heard what you often hear with agent-based models, which is this doesn't tell us anything we didn't already know. So one of the things we were talking about is teachers moving around the school and crowdedness being a problem, which is maybe true and fine. But really importantly, what that did is it led to really nice discussions around how they might intervene to increase teachers moving around the school. And also why teachers don't do that. And it's a question that they hadn't really talked about openly before, and this model enabled them to kind of think about these things and kind of discuss it. So although the beginning may seem simple, the kind of having this dynamics as a discussion point, a boundary object, was really great. It also introduced ideas around staff welfare, which is something we hadn't really thought about in SOCITS at all. So I'm now just going to talk a little bit about how the last two together. So in the first two, this is really the sort of methods that we used to build our model, right? We took lots of different perspectives and discussions and iterative discussions, and we developed rules, and I put them in a computer and have my little dots moving around. Those things that even if you're not sort of a coder or anything, you can do yourselves, right? You could ask these kind of questions and use our model, you know, as a boundary object essentially to discuss around. But if you do have some more coding ability or you're interested, you can begin to like build these models and examine sort of dynamic consequences and test out ideas for different interventions. One way you can do this. So what we have is this shiny to basically, so if you, I'm just going to share my screen. Cool. Corinna, can you see that, not the slides, the model?
Yes.
So if you go to jimallenglasgow.github.io, sockets_abm_demo, this is essentially where the model is. This is not going to be the final model. We are still working on it. But if you wanted to play around with something, you're very welcome to go to this website and kind of have a look. We will be updating it and improving it, but essentially what you can do is do something like, so here are all our dots, and we can kind of update the time a little bit, move them along, and then update model output. And we can also look at kind of how stress changes through time. For 4 agents, this dashed line is essentially the mean stress. And we can kind of do it for a number of random ones. We can also look at where our agents are stressed, and so we can kind of update this a little bit. This will basically say there are 4 situations: corridors, classrooms, the canteen, and the toilet. And for each agent, we're going to get a color, which basically tells us how stressed individuals are. And this can begin to look at the heterogeneity of those. And there are all the settings down here. So we can change the stress decay rate, for example. So essentially this tells us how quickly stress disappears. So when it's very, very low, it means that stress disappears very slowly in each agent. When it's very, very high, it disappears very quickly. We could change the probability of teachers moving, probability of being in the toilet between classes, probability of eating lunch in the canteen. Also, we have these parameters here, which are very useful and interesting, and also kind of match what Corinna was talking about at the beginning with these kind of groups emerging and stuff. This tells us basically how many friendship groups there are. So how many sort of individuals have strong friendship ties, or how many groups of strong friendship ties we have. And then we have this probability of following our friends around or moving with friends. And so we can change all of these parameters, update our model, it'll run, it'll take a little while. But basically what we can do, and if you want to have a play around and have a look, you're very welcome to go, and I can kind of describe it a little bit more. Yeah, and as always with these webinars, please get in touch if you are interested and want me to kind of talk through this more. But yeah, so let's just see how that is going. I'll come back to that in a minute. Let's just wait. Yeah, and I tend to have low numbers of individuals and whatever, so that's reached the end. I wanted to do time, so let's do that, and it could up. Okay, there we go. So this now is slightly different parameters, and we can begin to look at different perspectives. The same is true kind of here. So basically we can set rule numbers to 0 in that shiny or in our model and say, okay, we're not interested in social support or something like that. And then we can have a look at what that does. So here on the left, I have the entire model, just some stress profiles. On the right, I have only the information the students provided in our workshops. And this therefore tells us, okay, what are the sort of things that are happening? Finally, I kind of want to talk about this idea of nonlinearity and running the model and having a look. So I'm just going to give you a graph here. Stress decay is on the x-axis again, how quickly might stress decay. On the y-axis is mean stress, and so basically taking an average of stress of all the agents in the model. Teachers could be stressed, so they're included in that as well. And what we can do is we can run the model 10 times, taking average of the stress and plot it. and we get something like this, which is not that surprising. Stress kind of decays like this, and so you'd expect for very low stress decay individuals to be much more stressed than for higher stress decay. But what we can do then is, this is basically a perspective where it's only the interactions. So it's only kind of negatively interacting because you're stressed, or other rules that are in there, some based on uniform and things like that. But I haven't included ideas around rooms being differently stressed or time being differently stressed. What I can do is, if I add room variation, okay, so now what I've done basically is, in the model, added 0.1 sort of average stress in each room. So some might be a little bit lower and some might be higher. The important thing here is the stress that's being added is not just 0.1, is actually much, much higher. And so what we're getting here is feedback, essentially. So even if you sort of add a little bit of stress in our model, that causes some individuals to be slightly more stressed than they were before, which means that they might negatively interact, which means that they become stressed, and then they go to the canteen and they make everybody stressed. And then we can add time variation as well, so it could be a stressful room and exam time. And again, what we see is this curve shifted up, and actually we get sort of quite big increases in stress when it doesn't decay. And what we could think about then is, well, how do we affect this? What does this tell us? Could we think about intervening by, in exam time, sort of making sure we reduce that stress, or giving coping mechanisms? And one of the reasons I presented this is giving coping mechanisms is one of the things that were suggested by the students. So what are our conclusions? By taking the framework around ABM and dynamics, we can ask questions which can help us better understand different perspectives in schools. Models can act as really useful points of discussion within schools, so even having your little dots moving around and talking about that is a really effective way of understanding kind of dynamical processes. Also, once we have our model and we're happy with it, then we can actually really begin to understand how schools may change through time, and also these dynamics can help us think about ways we can implement change. What's missing? One thing I haven't said is anything about matching this model to data. That is a very technical thing, and I'm not going to touch on it today. But if you're interested, please ask, or we can have other discussions about it. I just want to thank all the SOCITS team, and also the youth advisors and the participants in our workshop. And yeah, if you have any questions, again, I'm going to advertise that there's one last webinar on Thursday. And then here are some questions again as well, kind of from what I've described. Is there anything that you would put in a model, or anything we're missing? I haven't described the whole model, but if there's anything that jumps out, what would be useful for you to know from a dynamical model for your research, and what interventions would you like to see tested? Because we're just about to sort of try out some interventions and things like that. So thank you very much.